All right, so proving these two trig identities, I put the identities up here that are super important that you should have in your brain. Okay, the Pythagorean identities are over here, and then these are all the regular common ones, which of course looks like they lost some things there. So, sine is 1 over cosecant theta, cosine is 1 over secant theta, secant is 1 over cosine theta, cotangent is cosine over sine that is 1 over sine. Cotangent, the one this is the one we really want. I wrote it up there. Cosine over sine, and then this one is sine over cos. That's the one we really want. The ones I highlighted, you don't really want to use the ones I wrote above. So I'm not going to write this one in because you're really not going to use 1 over cotangent, and over here I wrote the one we use here. Okay, so on your sheet, this is already written out with the information in there. So now we're going to do these. Let's see, the first one, what I would want to do with this guy is, since this is just a term over here, I want to try to get this to be one term. So to do that, I want to split this into 2 fractions. So I'm just going to rewrite 1 over cosine squared, and then I'm going to write cosine squared over cosine squared. This is one way you can do this. There's another way to do it also, but let's just try it that way. Okay, so for number 1, I can do this fairly easily if I look and I see that this right here is a Pythagorean identity. Okay, so that is 1 minus cosine squared goes with this Pythagorean identity if I rewrite it. Okay, so if I rewrite it to get, if I bring this over here, that would give me 1 minus cosine squared. So 1 minus cosine squared would give me sine squared. So if I bring the cosine squared over here, I'd have 1 minus cosine squared, which would give me sine squared. So I'm going to use that. That's the quickest way to do this one. So 1 minus cosine squared is equal to sine squared x. And that's all over cosine squared x. Okay, now again, go back to your identities, and just because they're squared, they're both squared, which is a good thing. So if you look at sine over cosine, you look for that, we find out that right here, tangent is equal to sine over cosine. So if we square both of them, it's just going to be tan squared, which is what we were looking for. So this is equal to tan squared x, which is that identity. So check on that one. Okay, on my next one, let's see. I'm going to see, now when I look at this one, I see that I do want 2 terms at the end. So I see I want this. I also see that right here, this one might be one where I'd want to use the conjugate to do it. So what that means is the conjugate would be 1 plus 2 sine, and I would need to multiply that by both the numerator and the denominator. I'm not going to touch the right side again. So let's try that one like that. So I'm going to multiply the numerator, and I'm going to use the space up here. So now I'm going to have cosine squared x, and then I'm going to multiply that 1 plus sine x. Okay, I'm not going to actually do the multiplication though. And then in the denominator, I'm going to do 1 minus sine x times 1 plus sine x, which is these 2 guys. That's what I just multiplied the both of them by 1 over sine x, 1 plus sine x. Okay? So in the numerator, I'm going to leave that alone a second. When I do this foiling, I know it's going to turn out to be 1 minus sine squared x. That's just a special thing. Okay, So I'd have cosine squared x times 1 plus sine squared, it's just sine x, no square on that one, sorry. Okay, and that's going to be all over 1 minus sine squared x. Okay, now I'm going to look back at my Pythagorean identities again, and I'm going to use that same one I just used a second ago in the last problem. So this guy is related to this right here. So if I look at this, and I take the sine and I subtract it from over, if I subtract it over on this side, I'd have 1 minus sine squared x, which would equal cosine. So if I take the sine squared x and subtract it over here, I'd have 1 minus sine squared x, which is going to give me cosine squared x. So that is what I'm going to use now. I'm going to replace the denominator. So I'm just going to cross it off here. And I'm going to replace that denominator with cosine squared x. Okay, so now if you look at what you have, hopefully you'll notice that we are now going to cross something off. So we can cross this off with this, and lo and behold, we're left with 1 plus sine x, which is what I wanted. Okay, so check, check, that one works. Okay, so this one's a little bit different. What I'm going to be thinking about doing is I'm going to want to factor this one because I see that there's a secant squared x in this. So this guy, I'm going to factor him and then see where I go with that. Okay, it's a little different because when we factor, we're factoring out a trig function, not like numbers. So when I factor this, guys, I'm going to take out a GCF. So I'm going to take out a secant x. So that's going to give me a secant x, and then it's going to be, it's not a secant x, I'm sorry, that's a 1 here. So I'm going to have 1 minus, and then this would just be a sine squared x. I'm not going to touch the right side, okay, because if you go and you FOIL it, right, if you go FOIL it back, if you FOIL it, you'd have secant times 1 is secant, and then you do secant times sine would be this. Okay, so when you go and check, that's what I just did. I just basically undistributed it. That's the factoring. We took the GCF out. Okay, so now I'm going to look at this, and this is just like what we just did a minute ago. This value right here. Okay, so this guy right here is a Pythagorean identity, right? It goes back to cosine squared. So cosine squared plus sine squared is equal to 1. That identity. Okay, so if I shoot this sine squared over here, wouldn't that be 1 minus sine squared would equal cosine squared? So that is what I'm going to do here. So now I have secant x, and then instead of 1 minus sine squared x, I'm going to write times cosine squared x. Okay, I'm sorry, this is secant. I took out a secant squared. All right, so now I look at this. Okay, I'm almost there. I want to get to 1, and that's not 1 right now. So I'm going to take the secant. I'm going to take this secant value, and I'm going to think, well, what is that equal to? Well, that is equal to 1 over cosine. It's the rainbow. Secant and cosine go together. So this would be 1 over cos squared x. All right, and then we have cos squared x here. I'm going to put it over 1 just so it's more obvious. Okay, now bam, look. These guys are going to fall out, and we are left with 1, which is what we were shooting for. And you are done.